Good day, math learners. Now let's talk about the fundamental counting principle. So the fundamental counting principle states that if one event can occur in m ways, and another event can occur in n ways, and a third event can occur in p ways, and so on, then the sequence of things can occur in m times n times p ways. Okay? So, to understand the fundamental counting principle better, let's have it in examples. So let's have example 1. Suppose two-digit numbers are formed from the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's important in every problem that we should take note of what are given in the problem. So here we are given these digits, in which we'll use these digits into forming two-digit numbers. Okay, we'll form two-digit numbers out of these given digits. So first question, how many two-digit numbers can we possibly form? So highlighting that we are asked about how many two-digit numbers can we possibly form, then let's represent these two-digit numbers into circles. You may also use squares, it's up to you, but in this example, let's use circles. So for question A, I'll represent two-digit numbers using two circles. Two circles because again, we have here two digits. Okay, so we have here already two circles. So between the circles, okay, write the multiplication symbol. Okay, now in the first circle, we will write there the number of options that we have for the first digit. And for the second circle, we will write there the number of options that we have for the second digit. Okay, so since in question A we are asked how many two-digit numbers can we possibly form out of our given digits here, and we know that the first digit cannot be 0. So meaning to say 0 cannot be an option for the first digit. So we are only left with 1, 2, 3, 4, 5, 6, 7, 8, and 9 as possible digits for the first digit. So the number of options that we have for the first digit is only 9. So for the first digit, we only have 9 possible options. And for the second digit, 0 can be a second digit already. So we have 10 possible values or 10 possible options for the second digit. Multiplying, we have 9 times 10, that's equal to 90. So answering question A, we'll say that there are 90 two-digit numbers that can be formed out of the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now question B. How many of these numbers are even? So we know that we are still referring to the two-digit numbers that we are supposed to form out of these given digits. But this time, we are asked how many of these two-digit numbers are even. So still, applying the fundamental counting principle for letter B, we'll still have to make use of our circles. And we already know that the first circle will contain the number of possible options for the first digit, and the second will be for the second digit. So for the first digit, we know that we can't include 0, so we only have 9 possible options for the first digit. Now for the second digit, we are asked for the even numbers. So we know that even numbers are numbers that are divisible by 2, or simply put, numbers that end with 0, 2, 4, 6, and 8. Okay, so we have here 0, 2, 4, 6, and 8, and we have 5 options because there are 5 even numbers out of our given digits here. So our options for the second digit will be 5. And multiplying 9 times 5, it will give us 45. So to answer question B, we'll say 45 of these numbers are even. Next, how many of these numbers are odd? So still following the same process, we'll still have to make use of our circles to represent the 2-digit number. And then, okay, so for the first digit, we know that we cannot use 0, so we only have 9. And for the second digit, okay, here, what we are asked are odd numbers. So odd numbers, of course, we know that odd numbers end with 1, 3, 5, 7, and 9. And we have 5 possible options for the second digit. So we'll write 5 for the second circle. Multiplying, it will give us 45. So to answer question C, we'll say 45 of these numbers are odd. Next, how many of these are less than 50? So how many of these numbers that we can possibly form out of the given digits are less than 50? So first, we'll still have to make use of our circles. So for letter D, so okay, for the first digit, again, we'll go back to what is asked in our problem in letter D. So it says here, how many of these numbers are less than 50? And we know that the numbers that are less than 50, that we can form 2-digit numbers that are less than 50 that we can form out of the given digits are numbers that starts with 1, 2, 3, and 4. So meaning to say, we only have 4 digits or 4 options for the first digit. And for the second digit, we already have 10 because we can use 0 up to 9. So we have 10 possible digits for the second, 10 possible options for the second digit. So that's 4 times 10. That would be equal to 40. So 40 of these numbers are less than 50. Okay? Next, how many of these are greater than 49 but less than 50? Okay, this time let's highlight first this part. Okay? Greater than 49 but less than 70. So what are the numbers that are greater than 49 but less than 70? Of course, these are numbers that start with 5 and 6, right? Because we only have 50 until 69. So still using circles for letter E. For the first digit, we can only have the digits 5 and 6. So we only have two possible values, two possible options for the first digit. And for the second digit, we can already use 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 10 options for the second digit. Multiplying 2 times 10, it will give us 20. So to answer our question on how many of these numbers are greater than 49 but less than 70, then we'll have 20. Okay? Now let's have our second example. So we have here, a cell phone service provider offers 2 free smartphone apps. If there are 24 different apps to choose from, so we have 24 different options. We have 24 different options of apps. How many different combinations of 2 apps can a client have? Okay, so again, we have 24 different options to choose from, and we are about to choose 2 apps. So meaning to say, applying the fundamental counting principle, we'll make use of alright. Okay, so we'll make use of 2 circles. So we know that the first circle is for the first app that we'll choose, because again, we'll have to choose 2 apps. So this is for the first app, and the second will be for the second app. The second circle will be the number of options for the second app. Now, for the first app, how many options do we have? Since we have 24 different options, so technically we have 24 different options to choose from for the first one. So for the first app, we have 24 different options. And since we have already chosen 1 app for the first option, then we'll only have 23 options for the second app. Multiplying 24 times 23, that's equal to 552. So answering the question, we'll say there are 552 possible combinations. Possible combination of apps. Okay? Let's have our third example. So in a make-your-own pizza parlor, a customer can choose between a thick or thin crust. So let's underline that. For the meat topping, the parlor offers a choice of bacon, pepperoni, sausage, or ground beef. For the veggie topping, the choices are mushroom, onion, or green pepper. And for the cheese topping, one can choose from mozzarella, provolone, blue cheese, or cream cheese. Okay, so question: how many different kinds of pizza can be made? So applying the concept of fundamental counting principle, let's make use of our circles. So the first circle will contain the number of choices for the crust. Okay? For the second, the second circle will contain the number of choices for the meat topping. So let's have it as empty. The third circle will contain the number of options that we have for the veggie topping. So that's VT. And for the cheese topping, okay, that will be our fourth circle. And let's have it as CT. Okay, now look at, now our pizza can be made out of the combination of the crust, the meat topping, veggie topping, and cheese topping. Okay, so now let's identify how many options do we have for the crust. Here we only have thin or thick crust, so we have 2 options for the crust. For the meat topping, we have bacon, pepperoni, sausage, or ground beef, so that's 4. For the veggie topping, we have mushroom, onion, or green pepper, so that's 3. And for the cheese topping, we have mozzarella, provolone, blue cheese, or cream cheese, so that's 4 options. Now multiplying 2 times 4 times 3 times 4, it will give us 96. Okay, so answering our problem, we'll say there are 96 different kinds of pizza that the parlor can make. Okay, so again, that was the fundamental counting principle, and I hope you learned something. See you in our next video.